Hey everybody, we're going to be looking at 2.6 today. And basically the idea of 2.6 is we're going to be looking at all the different things a parabola can tell us. Vertex, x-intercepts, y-intercept, line of symmetry. And there's a lot of good information here. However, it's going to take a little bit longer. And it's not because any of the concepts are difficult or challenging. It's because there's just so many little pieces that we got to put together today. So I'm going to try to go quickly and squeeze this into one video, but it may be two videos by the end. Okay, so really quick, looking at our starters, we're going to start with a point at -5, +3, and we're going to flip it over y. Now remember, when we flip over y, all we're really doing is changing the x value to a positive x value in this case. We're going to change the sign from negative to positive. And then we're also going to flip it over the x-axis. So we're going to change that y value to a negative, and we're just changing the sign. So -5, -3. Okay, and that's it for that one. Okay, so this one goes here, and then this one goes here. Okay, so for this one, we're actually not going to do that second one. I want to have room to do the first one. Give me 1 second. And it's gone. Okay, so for that first one, what we're going to be doing is we're going to be looking and checking and seeing if these are linear. And if they're linear, yay, and if not, why. Okay. Now remember, for any linear relationship, I'm always going to have a slope that's the same throughout. Okay, because a linear function has a slope that never changes. So really, I just need to pick 3 of these points. I'm going to pick these 3 points, and I'm going to check the slope between them. And if the slope's all the same, then I'm probably good. Unless the graph does something really funky later, I'm probably good. Sorry, excuse me. So starting out with this first one, I'm just going to look at these first two. Remember delta y over delta x. So the change in y is over the change in x's. So 55 minus 22 over 5 minus 2. So I get 33 over 3, or 11. Okay, now I'm going to do these last two, or these second two. 110 minus 55 over 10 minus 5. I'm going to get 55 over 5, or 11 again. Okay, since I have the same slope here, there's a good chance at that point that you're good. If you wanted to check all of them, you could, but that's a lot. Okay, and again, really, if you've got a set of data and you're telling that there is a relationship between them and the slope's the same every time, then it's going to be linear. Okay, so today's essential question, we are going to be looking at a lot of different parts of quadratic functions. First thing we're going to look at is symmetry. So remember, if I have a graph, let's make it offset a little bit. Remember, symmetry was where I could fold something and it'd be the same on both sides, okay? So the nice thing about parabolas is the vertex is going to be always where the line of symmetry is. Well, remember, the line of symmetry, or the vertex came from HK. Remember, changing H, the sign, because of that negative inside. But it's always going to be HK. Well, this line, remember, lines need to be described as either x equals or y equals, okay? If it's a horizontal line, it's going to be that y equals, and if it's a vertical line, it's going to be that x equals. And if it's not, if it's something like, this, that's going to be described in both terms. But if I have a horizontal line, it's just y equals. If I have a vertical line, it's just x equals. Well, in this case, it should always be x equals, because I'm going to have a vertical line. If I had it turned to the side, it's no longer a parabola anymore. It's described as the square root function, both positive and negative. So since it's always going to be facing up or down, I'm always going to have that vertical line, or x equals. So your answer, anytime it has to describe symmetry, your answer should always be in that x equals form. Okay, well, the x value for that vertex is is h. It comes from the vertex form. That's the nice thing about this. So it's always going to be x is equal to h. So if this here was 3, 2, then my line of symmetry here is just going to be x equals 3. Okay, so this is another nice thing that the vertex form gives us. We're going to be looking at vertex form today. We're going to be looking at standard form. Remember, standard form is ax squared plus bx plus c. And we're also going to be looking at what we call x-intercept or factored form. So x minus p, x minus q. Okay. So starting out, we're going to look at Desmos because Desmos is a very powerful tool that I talked about, and I want to make sure that you're good at using it because then it helps you to do the work. Remember, I'm focusing on those three things this year: precision, modeling, and technology. I want to make sure that you guys are technologically sound going into the future. So starting out here, I'm going to take that function. I'm going to bring it over to Desmos. Okay, so start out at desmos.com, click on graphing calculator. And then we're just going to plug it in exactly like it is here. So f of x is equal to 1 divided by 2. To get it to come back up, all you need to do is hit right x. To make it go up to that squared, you're going to hit shift 6. That's shift 6. Squared minus 2x minus 2. Make sure I got that right. Perfect. Okay, so I could go throughout this thing and click on the thing and try to find the point, but if you notice, like it's definitely like really hard to find like 2. Like there, I finally got it. Okay, but there's a fast way to do this. You click on this little edit list or this gear icon, and then this table, what it's going to do is it's going to convert it to a table for you. Bam, there's all our answers. So I just need to take this table and plug them in. So negative 2 is at 4. Negative 1 is at 0.5. Negative 2. Negative 3.5. Negative 4. Oh, I need to keep going. It's easy. Just add more rows. So just click down here. We're going to do 3, 4, 5, 6. Okay. So 3 is at 3.5. 4 is at negative 2. 0.5 and 4. Okay. And then I can use these points to sketch on here. So negative 2, 4, negative 1.5, 0, negative 2. Oh, that's nice. That's a convenient thing. 1, 3.5, negative 2, 4. And if you notice here, look at these numbers. Sorry, this should be negative. Look at these numbers. These numbers are the same going in the reverse order, and they should be because this is my vertex. So what you're always going to find here is that you have that symmetry about the vertex. Okay, so again, please make sure you're using Desmos, use your tools, let it do the work for you. Okay, use the results to identify the vertex. Okay, so going back, right, vertex is here, right here. Find the vertical line. Okay, well remember, again, that's our line of symmetry. So my vertex is 2, negative 4. So then my vertical line is x equals 2. Okay, and what this last one's doing is saying, okay, well, remember that vertex is here, okay, and this is our A value. Let's double check that. Let's go back to Desmos, plug this second one in, see if it matches up. So that's what we're going to do. We're going to go back to Desmos, get rid of these points, we don't need them anymore, and we're going to type in f of x equals 1 divided by 2, and then x minus 2. That's already pretty close. Oops, that's why. There, now it's not already very close. But when I add the squared, it should be reasonably close. It just needs to move down a little bit, so minus 4. Okay, and what we find is that is the same spot. So that's all that last part is asking us to do. Okay. So again, this is just asking you to repeat the idea. I'm going to leave this up to you to take the time to do. If you do have questions, please make sure you're showing up during those office hours or during the Art Guide Fridays. Okay, so looking here, Label the vertex and axis of symmetry. Graph this guy. Okay, so coming back over to Desmos. Let's get rid of these two functions. Again, let your tools do your work. I will let you know if there's ever a time where I don't want you using Desmos or a graphing calculator. -2 x plus 3, right? And plus 4 squared plus 4. Okay, so again, let's convert this to table. Okay, and that's going to give us that. Ooh, it didn't give us a vertex nicely. But if you notice, if you click on the line, it gives you a couple dots here. And these are what we call critical values. Critical values are values that are going to be important when you're using a function. Okay, things like x-intercepts, y-intercepts, vertices, any intersection points. Okay, so here's my vertex, done. Which I should have been able to just look at this and get, right? And then my axis of symmetry is just the x value here. So x equals -3. Okay, and that's what this is showing you here. But now we're looking at this form. Okay, so when I have standard form, I can take -b over 2a. Now you could do completing the square to get the vertex form. And if you remember how to do that from last year, great. If you don't, you don't need to. You just need to know -b over 2a. Okay, if you know -b over 2a, that's the x value for your vertex. And if you have your x value, well, you could always just plug that in to get your y value. But if all it's asking for is the line of symmetry, then you're done. -b over 2a. So let's look at that. So first off, it says label the vertex and the axis of symmetry. It's actually faster to do axis of symmetry first. So let's do that first. And we're going to do it the long way first, and then I'll show you how to do it. Or you already should know how to do it in Desmos. So we're going to do -b. Now I do need to keep this negative here. So -6 over 2 times 3. Negative gives me a positive. So my axis of symmetry is going to be x equals 1. And then what I can do for the vertex is plug that back in. So I'm just going to take 1 and plug it back into my equation. So 3, 1 squared minus 6, 1 plus 1. 1 squared is just 1 times 3 is 3, which is minus 6. 6 times 1 is just 6 plus 1. So I'm going to have 3 minus 6, which is -3, plus 1, which is -2. This is my y value. Okay, so this is my axis of symmetry. And then my vertex is going to be at 1, -2. Okay, so let's take this over to Desmos, double check everything. So we have 3x squared minus 6x plus 1. And I check my vertex here, 1, -2. Yay. Okay, so again, depending on what form you're in, we want to make sure we're doing the right thing. Okay, it's really, really nice when we're already in vertex form. There's my vertex. There's my vertex. My vertex here is -1. Change the sign. And then I don't have anything, but I can add 0 and not change it. There's my vertex. There's my line of symmetry. Okay, and then we take that over to Desmos and graph it. Oh man, here's my vertex again. Okay, this was negative, so it's going to become positive. This stays the same. Okay, again, these ones take a little bit more work, but it's just -b over 2a. -2 over 2 times 1. Maybe -2 over 2 or -1. That's my axis of symmetry. For the vertex, I need to take that 1 or -1, sorry, plug it back in. Now remember, put these in parentheses. Always put these in parentheses because then you're never going to mess this part up. Because if you don't put parentheses here, it's going to do the 1 squared and then make it negative. But you want -1 squared. Negative times a negative gives me a positive, which is what I need. I don't want a negative in the end. Okay, plus 2 times -1 minus 1. So this is going to turn to 1. It's going to turn into minus 2, minus 1. So we're going to have negative 2. So my vertex is at negative 1, negative 2. Okay, minimum, maximum. Okay, so minimum and maximum, it's another thing, but really it's something you've already done. The nice thing about minimum and maximum is it's really just where the vertex is. Think about parabolas, right? If I have a parabola, my minimum is going to be here. If I have a parabola that faces down or opens down, my maximum is going to be here. Okay, for this one, I don't really have, the first one, I don't really have a maximum because it's going to go on forever. And then for this one, I don't really have a minimum because it's going to go on forever. It's going to be negative infinity or infinity, as the case may be, which is not usually interesting to us. So we don't worry about those global maximums in that case or minimums in that case. Okay, we're looking at the ones that we really care about. The nice thing here is too, if I know where that point is and I have a parabola, right? Anything to this side, this side is going to be decreasing. As I come left, it's going to be decreasing. I hit that minimum. It's going to start increasing again. Okay, so like here, let's check this way. So like here, let's get rid of the, come on. There we go. So let's use colors here. Negatives is going to be red, okay, or decreasing is going to be red. So if I have a parabola where a is greater than 0, or it's positive, I'm decreasing until that minimum. And then blue, I start increasing from the minimum. Always go left to right. For this other one, as I come left, I'm increasing up until that maximum, and then I start decreasing again. Okay, so this one asks us to find the minimum or the maximum. Okay, it's positive. Positive tells me that it's going to be opened up, so I should have a minimum. Okay, so first, let's take this and find the minimum. Okay, so negative b over 2a. So negative negative 2, that's important, over 2 times 1/2. This is going to be positive. This is going to be 1 or just 2. Plugging 2 back into my equation. 1/2 times 2 squared minus 2 times 2 minus 1. 2 squared is 4. Divided by 2 or multiplied by 1/2 is going to be 2. Minus 4 minus 1. So negative 2 minus 1 or negative 3. Okay, so my vertex is at 2, negative 3. And in this case, this is going to be also my minimum. Looking at the domain and range. Domain. Always, 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 for parabolas, the domain is all real numbers. Always. Never changes. Okay, assuming it's truly a parabola, it'll always be all real numbers. Okay, the range, though, is all the y's that work. Okay, well, let's think about this logically for a second. If this is the smallest y I can get, and I know that because it's a minimum, then y has to be greater than or equal to negative 3. If it was the other way around, then it would be less than or equal to negative 3. Okay, now again, this parabola here goes like this. It opens up because it's positive. A is positive. My vertex is here. Now, when I describe, the only time, this is the only time you describe things in terms of y, is range. It's the only time. Minimum or increasing, decreasing is always described in terms of x. Go back here. Decreasing to the left of, increasing to the right of. So it's increasing to the right of the x value here. So increasing to the right of x equals 2. And then to the left of X equals 2. Okay, properties of graphs. So what this one's showing you is that vertex form. Okay, well think about this. I have two x-intercepts. And again, that vertex should be in the middle of those because of that symmetry that I have. So all this is showing you is that if you know what P is and you know what Q is from the x-intercepts, you just got to take those, put them together, and divide by 2. So for example, and again, nothing on front here matters. I'm just looking here, here. Now I do need to change the signs because of these negatives. I need to change the signs. So I'm going to have -3 plus 1 divided by 2. So -3, sorry, -2. Let's actually do some math there. Over 2 or -1. Okay, this is going to be my axis of symmetry. My x-intercepts, already did those. So that's x equals -3 or 1. And then my vertex, I just need to take that -1, plug it back in. So -2, -1 plus 3, -1 minus 1. -2 times, so that's what's happening there. This is going to be +2. This is going to be -2. -2 times 2 is -4, times -2 is +8. So then my vertex is at -1, 8. So that's my vertex. These are my x-intercepts. And then x equals, you write it correctly, -1 is my axis of symmetry. Okay, again, more practice here. Refer back to the last slide. I'm trying to keep this video under 30 minutes for you guys. If you get stuck, please let me know. And then the writing prompt here. So again, what this does is it brings it all back together. From this formula, okay, I can factor and find x-intercepts. I have my y-intercept. I can get the axis of symmetry. There's a lot of information here that helps me to graph these things more precisely, okay? Do we always need to necessarily be super precise? No, but remember, precision is one of those focuses we're looking at this year. Okay, remember that you're stopping in for office hours if you need them, or for RTI Fridays. This is the last lesson. So next time you will have a half-day review and then a half-day mini test quiz thing. Okay. If you have any questions, please let me know. Please reach out to me. Have a great day.